So at this time, please welcome to the stage Jennifer Buckley, NASA ISS Program Chief Scientist, and Megan Everett, ISS Program Deputy Scientist at NASA Johnson Space Center. We got some amazing awards here, and we're going to distribute these right now. So welcome to the stage.
All right, welcome everyone to our second day of awards. I am very honored to be here to present these outstanding scientific achievements and introduce the great work they're doing with Jennifer Buckley and Jim. All right, so today we are going to present our compelling results, and this award recognizes cutting-edge research projects that have published promising results during the last year. Our first award is Dr. Ethan Elliott at NASA's Jet Propulsion Laboratory. And he earns this award for compelling results in physical sciences and materials development. He led a team that used the Cold Atom Lab for the first ever observation of dual species Bose-Einstein condensates and dual species atom interferometry in space. This achievement leads directly to exploring the physics of ultra-cold, multi-species quantum chemistry in microgravity, and it paves the way for a new class of ultra-precise quantum sensors. Terrestrial quantum sensors, like atom interferometers, have been extremely sensitive, and moving them to space can increase the sensitivity by orders of magnitude. Dual-species atom interferometry in space is the ideal way to test Einstein's general relativity principle, considered the holy grail of fundamental physics. And our second award today goes to a compelling result in human health in space to Dr. Ron Wilderborders van Oostenhout, formerly of Leiden University Medical Center and now at Zons Medical Center in the Netherlands, for observing a significant increase in headaches in astronauts during spaceflight and exploring their underlying mechanisms. The teams used questionnaires and general health assessments to determine that 92% of astronauts, even those with no prior history, experience headaches during spaceflight. Headaches were more intense and more likely to be migraine-like during the first week of flight. This may be explained by the increase in pressure inside the skull, but further research is needed to clarify the mechanisms. This work informs efforts to develop therapies for astronauts and provide insight into headaches that people here on Earth have. Dr. Van Oosterhout is not able to join us today, but he does extend his gratitude for this award and is looking forward to more research in this area on the International Space Station. All right, moving on. Our third award today is to Dr. Robert Green at NASA's Jet Propulsion Laboratory, who receives a compelling result in earth science and remote sensing for the Earth's surface mineral dust source, or EMIT, investigation. This captures high-fidelity spectroscopic images on the Earth's arid regions. Mineral dust blown into the atmosphere from these regions affects local warming and cooling, air quality, snow melt, and plankton growth in the oceans. These effects vary with the type of mineral. Dark-colored particles absorb the sunlight and increase heat, while light-colored particles can have a cooling effect. EMIT creates a map of the type and distribution of mineral particles that help us understand dust effects on Earth and on humans. The instrument also images coasts, urban areas, greenhouse, gas emissions, and other features for a variety of research and monitoring purposes. Please welcome Dr. Robert Green. Congratulations. All right, and our final award today is for Dr. Tatahiro Mihara at Riken and Dr. Hitoshi Nagoro of Nihon University, and they are receiving a compelling result in physical sciences and materials for development for outstanding contributions to the field of X-ray astronomy through JAXA's Monitor of All-Sky X-ray Image, or the MAXI instrument. This was launched in 2009, and MAXI has revolutionized our understanding of high-energy universe and resulted in more than 600 research papers on transient and variable X-ray sources. In a collaboration with NASA, X-ray outbursts from unknown objects detected by MAXI are observed in detail by NICER, which has led to an additional 550 published papers. MAXI has discovered 35 X-ray nova, 14 of them black holes. Extension of its operation until 2030 and the NICER collaboration hold promise for continued outstanding contributions to the field of X-ray astronomy. Dr. Nobuyuki Kaiwai of the MAXI team will be accepting the award on their behalf. All right, and that wraps up our awards today. So thank you all for joining us, and please come again tomorrow for the last day of awards to close out the ceremony.